Section 3.3, Solving One-Step and Two-Step Equations. So this video is basically going to help you solve real simple equations that involve either one or two steps. And the first thing we're going to do here is solve one-step equations that involve addition or subtraction there. So basically we're going to isolate the variable when we have an addition or subtraction sign on the variable side of the equation. Next thing we're going to do is solve equations where we have either multiplication or division, and then we'll put both of them together here and solve equations that have both addition or subtraction and multiplication and division. And so we'll start by solving some equations that just have addition or subtraction on the variable side. So when we solve an equation, we're identifying the value of the variable that will make the equation a true statement. For example, what must x equal to make the equation x plus 2 equals 3 a true statement? Well, we can look at this and say, well, kind of use a little guess and check here. If I put a 1 in there for x, I'd basically have 1 plus 2, which is 3, so then I have the statement 3 equals 3. So we can solve a simple equation like this just using the basic fact that 1 plus 2 is going to give us 3 to come up with an answer. Here's another example. What must x equal to make the equation x plus 27 equals 92 a true statement? Now, we could use guess and check again, but that is going to take quite a while, and it may not be that accurate. So this equation is too complicated to solve using basic facts. So what we're going to do is we're going to use a series of steps that get the variable isolated on one side of the equal sign. And so this is what we typically do when we solve an equation. We isolate the variable to solve the equation. So I'm looking at my equation here, x plus 27 equals 92, and I would ask myself, okay, what's keeping x from being all by itself? Well, it's this addition of 27 that's keeping it from being all alone. So we're going to undo that, and the way we undo that addition of 27 is by subtracting 27. Now, whatever we subtract to one side of the equation, I have to subtract from the other side of the equation. And this little problem here, 92 minus 27, is going to get us to our solution. When I do 92 minus 27, it's going to give me 65. Once x is all alone on one side of the equation, it's easy to see what its value has to be. And so this 65, if I plug 65 back up in here in the equation for x, 65 plus 27 will give me 92, and I'll end up with a true statement. So isolating the variable, getting it all alone on one side of the equation, is the way that we end up solving in equations. Let's take a look at a definition now. The addition property of equation lets us add or subtract the same number to each side of an equation to get an equivalent equation. Let's take a look at an example here. And I started with a really simple equation. 10 equals 10. That is a true statement. Now watch what happens. If I add 3 to both sides of the equation, I still end up with a true statement. I still end up with a 13 is equal to 13. Same thing happens with subtraction. If I start with a simple equation like 8 equals 8, and then I subtract 2 from each side, I still have a true statement there. And so that's what happens here, is if we add or subtract the same number to each side, it maintains the equality. And this is really important. It may seem like a really simple idea, but this is what allows us to isolate the variable and solve most of these equations. So let's see how this is going to work. So to solve an equation like x plus 2 equals 6, we isolate the variable by undoing the addition. So here I go. Okay, x plus 2 equals 6. To isolate x, we must undo the addition of 2. So we use the inverse operation, which is subtraction of 2. So I'm going to subtract 2 from both sides. Again, I need to do that in order to maintain the equality in the equation, just like you saw in the last definition there. So I subtract 2 and I subtract 2, and now I've isolated the variable, got it all alone, and then it's really easy to see what x has to be equal to. All right, let's take a look at some examples that will help you understand how to isolate a variable when we have just addition or subtraction on the variable side. All right, example 1. So I'm looking at my equation. I have a left side and a right side. Here is my variable side. So x plus 3, that's my variable side. I want to get rid of the addition of 3 to get x all alone. So I'm going to subtract 3 from each side. And then I'll have x all alone on the right side here. Sorry, the left side, because those 3's are going to subtract out or go away to 0. On the right side, 18 minus 3 is going to give me 15. All right. Example 2. Y plus 7 is negative 13. Well, I just need to get rid of the addition of 7 here to get y all by itself. So let's see. Y negative 13 minus a 7 or plus a negative 7 is going to give me negative 20 for that one. Okay. example 3, I have m minus 5 is equal to 11. So I really want to get rid of the subtraction of 5. And so I do that by adding 5. And I want to add it to both sides. On the left side, negative 5 and positive 5 are going to go to 0. So I'm left with m. On the right side, I'll get 16. Okay, question 4. Now my variable side is on the right side. So I'm not worried about this negative 6 or moving that or getting rid of that. What I'm really worried about getting rid of is this negative or minus 7, because that's going to get my variable all alone. So I'm going to add 7 to both sides. And negative 6 plus positive 7 is going to give me 1. Okay, question 5 here. I want to get rid of this negative 8 to get y all alone. So I am going to add 8 to both sides. Come around here to finish that. So on the left side, 12 plus 8 is going to give me 20. On the right side, negative 8 and positive 8 is going to give us 0. So all I'm left with there is y. Okay, question 6. Y plus 1/2 equals 3/4. Well, what I want to do here is I want to get rid of the addition of 1/2. Okay, so I'm going to come up here and give myself some room to solve this. So to get y all alone, I have to get rid of the addition of 1/2. So I'm going to subtract 1/2 from both sides. All right, the left side, which is the easy side, let's go ahead and do this. Well, positive 1/2 minus 1/2, that's going to give me 0. So I'm left with y. On the right side, I have to do a little bit of work here, though, because I can't subtract these fractions as they stand. I need to get a common denominator. So I look at my denominators of 4 and 2. The common denominator there is 4. This top fraction is good. That's 3/4. The bottom fraction, to get a denominator of 4, I'm going to multiply by 2. So really what I'm starting here with then is 3/4 minus 2/4, which is going to give me then 1/4. Okay, go ahead and pause your video player now and answer these practice questions. When you're done, hit play to see how you did. Okay, question 7. To get x all by itself, we need to undo the addition of 9. So I'm going to subtract 9. So then I'll get x equals 4. Question 8, it's the addition of 13 here that's keeping x from being all by itself. So I'm going to subtract 13 from each side. Let's see, x on the right side. Positive 6 and a negative 13 is going to give me negative 7. Notice this is a good answer right here, like that. I don't have to have x always over here on the left. X can be on the right. As long as it's isolated, we can see that x is equal to negative 7. Question 9, we're getting rid of the subtraction of 10 by adding it. So then y is going to be negative 7. Question 10, let's see, r, we need to get rid of the minus 2 there. So I'm going to add 2 to both sides. So r is equal to negative 3. Question 11, I want to get rid of the addition of negative 4, so I'm going to just add a positive 4 there. Let's come over here to finish. On the left side, 8 plus 4 is 12. On the right side, negative 4 and positive 4 give us 0, so I'm left with x equals 12. Okay, so I want to subtract 1/3 from each side. On the left side, it's easy. 1/3, nice, 1/3 gives us 0. On the right side, I'll have to get a common denominator here, which is 9. The top fraction's good. So my missing multiplier is 3, so that's going to give me 3/9. So 5/9 minus 3/9 is going to give me 2/9. Okay, now we're going to move forward now and solve equations of the form ax equals b. And this is just when we have multiplication or division on the variable now. Those first couple were just addition and subtraction. And so just like with addition and subtraction, we have the multiplication property of equations, which lets us multiply or divide each side of an equation by the same, and in this case it has to be a non-zero number, because if we multiply by 0, we end up getting 0 on both sides. So as long as we multiply by a non-zero number here, our equation, we will maintain the equality in an equation. And again, I gave you a real simple example here. Here's a really simple equation. 10 equals 10. And if I multiply both sides by the same number, I still maintain my equality. Same thing is true for division. If I start with a simple equation, 8 equals 8, divide both sides by the same number, I still end up with an equal or equivalent equation. Now let's take a look at some examples that will help you solve equations when we're going to undo either multiplication or division. Okay? Example 13. Notice here I have 3 times y. That's what's keeping y from being all by itself, is this multiplication of 3. So what I'm going to do is I'm going to divide by 3. And if I divide the left side by 3, better divide the right side by 3 to maintain the equality. So on the left side, I basically have 3 divided by 3, which is 1. And I'll write this out the first time. That's 1y. On the right side, I have 18 divided by 3, which is 6. Well, 1y is just the same thing as y. So typically when we get that 1 out front, we usually don't write that. I would normally go straight from here down to this answer. But it's important to see that the division is happening here so that we're left with 1y, which is the same thing as just y. All right, question 14. Here I'm multiplying by negative 2. Well, the inverse of multiplying by negative 2 is dividing by negative 2. Notice I don't want to divide by a positive 2 here because that would still leave a negative on this side of the equation. If I divide by a negative 2, negative 2 divided by negative 2 is again just positive 1, or x. So whenever we're multiplying by a negative number, we want to divide by that exact same negative number. Now if I divided the left side by negative 2, I'm going to divide the right side by negative 2 to give me an answer of negative 5. 15, I need to undo the multiplication of negative 7, so I'm going to divide both sides by negative 7. And I'll get y then is equal to negative 21 divided by negative 7 is positive 3. Okay, question 16. I'm going to come over here just to give myself a little bit more room. Y over 4 equals 8. I want to undo the multiplication of, I want to undo the division of 4 here. So to undo division by 4, I'm going to multiply by 4. On the left side, however, I'm going to write that 4 as a fraction. So 4 over 1, that's still just 4. So I'm multiplying the left side by 4. But since I'm dealing with a fraction here, I'm going to write this one in fraction form. On the right side, I also want to multiply by 4. Over here, I don't have any fractions, so I'm just going to write that 4 as it stands like that. Now let's take a look and see what happens here. You can see this common factor of 4. 1 4 in the numerator, 1 4 in the denominators. Those things are going to divide right out and give me 1. So you can see all that I'm going to have left on this left side then is y over 1. Well, y over 1 is just y. On the right side, 8 times 4 is 32, and I've got my answer. Go ahead and pause your video player now and answer these practice questions. When you're done, hit play to see how you did. All right, 17. We want to undo the multiplication of 6. So I'm going to divide by 6. So we get x is equal to 3. 18, we want to undo the multiplication of 8. So I'm going to divide both sides by 8. On the right side, I'm just going to get, on the right side, I'm just going to get x. On the left side, negative 32 divided by positive 8 is going to give me negative 4. All right, 19. I want to undo the multiplication of negative 5, so I divide by negative 5. On the right side, negative 5 divided by negative 5 is just positive 1, or 1m, which is just m. On the left side, negative 35 divided by negative 5 is positive 7. All right. Okay, question 20. I want to undo the division by negative 6. So I'm going to multiply both sides by negative 6. On the left side, I'll write it as a fraction. Right side, since I'm not dealing with fractions, I'll just write it as a whole number. All right, these common factors of negative 6 are going to divide right out for us. Leave us with y over 1, which is just y. And then 5 times negative 6 is negative 30. Solving two-step equations. So to solve equations, we follow a specific Solving two-step equations. To solve equations, we follow a specific procedure that is organized into 4 steps. So here are our 4 steps we use to solve or isolate the variable to solve the equation. So the first thing we do is we take a look at each side and we simplify each of the sides independently. Second step is we get all the variable terms to one side of the equal sign. We can't isolate a variable when it's on both sides of the equal sign. So we have to get them all to one side first. Once we get all the variables to one side, then we're going to undo addition and subtraction on that variable side. Then the last step is going to be undo multiplication and division. And notice that steps 3 and 4 are the reverse of the order of operations. Order of operations, we always did multiplication first, and division first before we did addition and subtraction. Well, when we undo that sort of thing in an equation, we reverse that, and we undo addition and subtraction first, then go to multiplication or division. So depending on the complexity of the equation, we may need to use 1, 2, 3, or all 4 steps up here. Here we'll focus on equations that are solved only using the last 2 steps. These types of equations usually have a constant term on both sides of the equal sign. So here you can see that. I've got a constant term on the left side of the equal sign and a constant term on the right side of the equal sign. And notice on the variable side now I have both addition and multiplication. And so what we do is we undo that addition first, then a multiplication second. And so here are 4 steps. But again, we're just focusing on simpler equations here that are going to use just the last 2 steps. So let's take up that last problem we just looked at. We're trying to get x all alone. We have multiplication by 3 and addition of 2. That's what's keeping x from being all alone. We're going to undo the addition or subtraction first. So I'm going to subtract 2 from each side, and I'm going to rewrite my equation. So notice I put my equal sign down there right away. I line it up and put it down there. Now I'm going to look at each side and see what's left on each side. Well, the left side is pretty good. Positive 2 and negative 2 is 0. So all I'm left with there is 3x. The right side, negative 4 plus negative 2 is negative 6. Now I'm just down to this last one-step equation. I need to undo the multiplication of 3. So I divide by 3. And negative 6 divided by 3 gives me negative 2. Now, we didn't do this in those last equations, but it's time for us to start doing this. We want to check and make sure this solution, x equals negative 2, is a good one. So we are going to plug that back into our original equation and see if we end up with a true statement. So here's what that looks like. Whenever I substitute a variable, I'm always putting an open set of parentheses. So basically, I'm rewriting the equation now, and I'm replacing x up here with the value that I just found, negative 2. We're going to see if it works. Okay? I'm going to just keep simplifying each of these sides now independently. The right side's pretty easy. It's already 4, so that's going to stay that way. On the left side, I would follow the order of operations. I'd multiply 3 times negative 2 to give me negative 6, and then negative 6 plus 2 gives me negative 4. Sorry, this side here was negative 4 as well. So I get negative 4 equals negative 4, and I would say, okay, a little check mark there to say, hey, this worked. Now, one important thing about a check is I want to bring it all the way down to this last step. So I get both sides of the equation equal to just one number, and they're both the same. Okay, I wouldn't want to stop. I see a lot of students stop their check right here and leave this last step up to the person reading their check. Well, we don't want to do that. We want to go all the way down, one more step here, until we get the same number and the same number. Now, had this not worked, we would go back and double check and make sure that our check was done correctly. And if our check was done correctly, that means we made a mistake up here when we were solving the equation. So we would go back here and rework this equation and figure out where our mistake was. Go ahead now and pause your video player and answer practice question 22. When you're done, hit play to see how you did. All right. Trying to get x all alone. I have multiplication of 4 to get rid of and the subtraction of 3. We're going to undo addition or subtraction first. So I'm adding 3 to both sides. On the right side, negative 3 and positive 3 is 0, so I'm left with just 4x. On the left side, a negative 11 plus positive 3 is going to give me negative 8. Now I'm going to undo the multiplication of 4 by dividing by 4. And so I get this statement now. X is equal to negative 2. Now I want to check that. So I'm just plugging it back into the equation here. The left side here is good. It's already simplified. It's just negative 11. The right side, now I would follow order of operations. 4 times negative 2 is negative 8. And then negative 8 plus negative 3 is negative 11. So I would say check. That worked. Go ahead now and pause your video player again and answer these 2 practice questions and check them. And when you're done, hit play to see how you did. All right, question 23. Trying to get y all by itself. So I would undo the addition of 17 first. On the right side, that's going to give me negative 4y. On the left side, that's going to give me negative 16. Now I'm going to divide out that negative 4. I was multiplying by negative 4, so I'll divide that out. And when I divide that out, it leaves me with just y on the right side. On the left side, negative 16 divided by negative 4 is going to give me positive 4 for my answer. Okay, now let's check that. So let's see, 1 equals negative 4 times 4 plus 17. Okay, I'm going to do the multiplication first. That's going to give me negative 16. And then negative 16 plus 17 is going to give me positive 1 for my check. All right, practice 24. Trying to get x all alone. I have both multiplication by negative 2 and addition of 5. I'm getting rid of the addition first. See, on the left side, 5's go away. I'm left with negative 2x. Right side, 3. Now I'm going to divide by negative 2. So x equals negative 3/2. And that's fine. We didn't get a whole number answer here, and it's okay to get fractional answers. Now I want to go ahead and check this back in the original equation. So I'd say, okay, negative 2 okay, so I write everything in there, put the negative 3/2 now in place for x. Now I'm going to multiply. Well, notice I'm taking negative 2 times a fraction here, so I'm going to think, all right, I'm going to write negative 2 as a fraction by putting it over 1. And hopefully you see here that I have a common factor of 2 in the numerator and a common factor of 2 in the denominator. So I'm going to divide that out. So that's going to give us 1 down here. When I divide a 2 out up here, it's going to give me a negative 1 left over. So that's what I'm going to multiply by now. So really, essentially here, I just have a negative 1 times a negative 3. Well, negative 1 times negative 3 is going to give me a positive 3. And then 3 plus 5 is going to give me 8. And I say, yep, that works.